Hi everyone, welcome to G World of Academic Physics. Today we will discuss some more illustrations on electric field that can help the student to uplift their thinking. Let me consider the question 1, how the questions is framed. This is a non-conducting ring having radius of the ring is r and charge q is uniformly distributed over this non-conducting ring. All over this charge q is distributed having radius is r. At the center of the ring a negative charge q is placed having mass is m, and what is happening, this charge is displaced a small distance x. The questions has framed, find the time period of SHM. What is the question is asking? Time period of SHM. Here the student must think about how the SHM is happening. What is the concept of SHM says, if we displace the charge from this position to this position, if it will again return back to its own positions, then there will be SHM can be happening. And this displacement is not a very large displacement. The x displacement is very small displacement. These are the assumptions that we have to consider. If the charge again return back to its original positions, then SHM can be happening. So initially if you look at this charge is exactly its equilibrium positions, because net force at the center of the ring is 0. Net force exactly at the center of the ring is 0. So charge is in equilibrium positions. This charge is now displaced to a small distance x. When this charge is displaced to a small distance x, now this charge will be here. And we need to think about what is the expression of the force at this point. We know due to ring, the expression of electric field on the axis of the ring, we know these expressions. What is the expression of electric field? At electric field on the axis of the ring, suppose I will give the point P, electric field is nothing but K Q x upon x square plus r square whole to the power 3 by 2. This is the expression of electric field on the axis of a ring. At this P point, this is the expression of electric field. And what is the direction of the electric field? The direction of the electric field is like this. This direction, it will be like this. And what is the expression of force? And we know expression of force at point P is nothing but the electric field of the ring multiplying this charge. If I will see carefully, this is kqx upon x square plus r square whole to the power 3 by 2 and multiplying the charge. If you observe carefully, if you will think about the direction, if it is a positive charge, definitely field these directions, so force will be this directions. But this is a negative charge. If the field is this direction, definitely the negative charge will experience a force in this direction, or definitely it will return back to its original position. So SHM will definitely occur. It means direction you can say towards the center. And what is that? KQ, this is Q. If it is better, I will consider this is small q. So I will put here small q to avoid the confusion of same charges. KQ, this is q upon x square plus r square whole to the power 3 by 2. This is x. This is in the format of like this. This is the net force experienced by this charge. If we compare these situations and I assume this thing that x is much more lesser than r, the displacement is a very small displacement. If this kind of scenario is happening, I can ignore this x in comparison to r. So F equals to, I can say minus k q upon, this is r square, this 3 by 2, this is r cube, this is x. This is the expression of the net force. If I will compare with these expressions, that F equals to minus kx, then I can easily get the value of k. Here negative, here also negative, kx, x is here. So what is the value of k now? K value is k q upon rq. This is the value of what? K. Once I get the value of k, I can easily say the time period is t equals to 2 pi under root m by k. T equals to 2 pi under root m by k. This is 2 pi. Mass of the particle is m, and what is the k value? I can substitute here k q, and rq is below and it will go upward. This is the time period of the SHM. One more time I want to express these things to my student. When this kind of things question is given in a non-conducting ring having charge is q, and a negative charge exactly at the center of the ring, and this charge is in equilibrium. What is happening? This charge is displaced to a small distance x. Now it is now in the point P. When we'll see the net force on this charge, if will displace this direction, if it will return back to its original position again, we can say yes, the SHM is happening. So we'll think about due to ring, non-conducting ring, what is the expression of electric field? Electric field of the ring into this charge, I will get the expression of the force, and I found that the direction of the force is this direction, because this is a negative charge. So definitely this force direction is this direction. So this charge is again returned back to its original position. So definitely this SHM is happening. And I assume that x is much more lesser than r. So ignoring these things, I will get the expression of the net force. This net force I will compare with this SHM equation, that F equals to minus kx. I get the value of k cube k upon rq, and I know the time period in this scenario is 2 pi root over of m by k. Simply substituting the value of k, I can easily predict the time period. I hope this question is clear. Let me do one more question so that student can easily predict how the questions are framed. Let me see the questions. How the questions are framed very carefully. This is two plates. This is two plates, and you will say this is positive plate and this is negative plate. I hope this is a positive plate, negative plate. Charges are uniformly distributed here. Charges are uniformly, negative charges distributed here. Due to this, the direction of the electric field will be like this, because electric field always from positive to negative. So it will be moved like this. And I said the length is L. This length is L. This length of this is a parallel plate. This is positively charged. This is negatively charged, and the length is L. So electric field always positive to negative. Exactly at the center, and I said this width, the width of the parallel plate, this is I said d. Exactly at the mid of the plate, you can say this distance is d by 2 and this distance is what? D by 2. A charge, positive charge q is projected with a velocity, you can say v naught velocity it has projected. At what velocity it has projected? It has projected with velocity v naught. The question is asking at what velocity someone can project this charge, it will not collide with this surface. It will not collide with this surface, because this is a positive charge, and definitely this whole thing will become like this. And everything what I am talking about here, this is charge, this charge is a positive charge, mass is m, and we are neglecting the gravity here. Neglecting what? Neglecting the impact of gravity. This is very important fundamental question. This is positively plate charge, this is negatively charged plate, and a charge of q, mass m, projected exactly at the mid with a velocity v naught. The question is framed at what velocity I will project so that it will not hit at the bottom surface. It will not hit at the bottom surface, neglecting the impact of the gravity. We are neglecting what? The impact of the gravity. This seems like a projectile question. When this kind of questions is framed, one must know how much time it will take. First, I know in this scenario, if this is height h and something has projected with a velocity v, it will be go like this, and what's its path and how much time it will take. the expression of the time is, we can easily use this concept that h equals to ut plus half gt square, and I know this is only horizontal velocity, there is no vertical velocities at this instant, so this section is 0. So h equals to half gt square, so t equals to 2h by g. A student must, t equals to 2h by g root over. A student must be very aware when this kind of scenario is given like this, what is the time taken the particle to reach at the bottom, the time taken is 2h by g. Once I get the 2h by t time taken, I can easily find the range of the projectile, and the range of the projectile is nothing but what? Range is nothing but the velocity into time. The horizontal velocity is v0 and time taken is 2h by g. So one student must think about, this is a combined question based on projectile and electric field. The expression is very clear. For the range, a student must use this formula. And how we can say it will not hit? If the range of projectile, range of projection of this charged particle or range of projectile must be greater than this length. If the range of this projectile is greater than this length L, I can say this charged particle will not hit at the bottom surface. And what is the range of projectile? This is V0 into 2. H is what? D by 2. And G is what? We already said gravity free space. So here we have to only consider the acceleration of the electric field accelerations, and we know that F equals to what? QE. So MA equals to what? QE. So A equals to what? QE upon M. This is the accelerations I will use here. So what I'll substitute here? QE by M root over, and this should be greater than equals to L. So what is the expression is coming? This is V0, and rest of the terms I am taking that side. If I'll take that side, the rest of the term, that will be coming like what? This is L, and this is QE upon dm, and this is what? And if I'll introduce this V0 should be greater than, you can say QE upon dm L square. So this is very fundamental thing, this much of velocity. So what should be my velocity so that it will not hit to this bottom surface? My velocity should be greater than this value so that it will not hit to the bottom surface. One more time I just want to say to my student, if the range of this charged particle greater than this length L, I can say it will not hit to this bottom surface. So what is the formula of the range? Range is nothing but velocity, horizontal velocity into time, and what is the time expression? That is 2h by g in this case of projectile. And this whole thing should be greater than equals to L, so definitely it will not hit at the bottom surface. So V0, so this range should be greater than L, so that's why it will not hit at the bottom surface, because the range is more, that's why it is more than L, so definitely it will not hit. So using this concept, I'll simply get the expression of the velocity. I hope this scenario is clear to all. I will do one more illustration to my students so that can help the student to think little better. Let me do one more illustrations. What is the illustration say here? Question 3. This is, the scenario is like this, and this is a positive plate. This is what? A positive plate, and this is a negative plate. So it indicates the direction of the electric field will be like this. The direction of the electric field will be like this. This is the direction of the electric field. And as usual, what is happening? We are projecting a charged particle. What is happening? We are projecting a charged particle, making an angle theta with the horizontal. This charged particle is Q, mass is M, and we are projecting this charged particle. Question is asking, find the value of this velocity of this charged particle so that it will not touch the upper surface. It means the maximum value of the velocity, at what maximum value at what maximum velocity I can provide, maximum velocity of projection, so that it will not touch the upper surface, not touch the upper surface. This is a very fundamental type of question. The student must have to think about it. So what will happen? It will, if I'll project like this, and everything is what? Gravity free space. We are ignoring what? The acceleration due to gravity. If this kind of questions has framed, what is the thing we have to think? And the width is here d, and the width is what? D. What if this kind of questions has framed? We have to think about it. What? The maximum height of the projectile. What is that? Maximum height of the projectile must be less than d. In that scenario, definitely it will not touch to the upper surface. The maximum value of the maximum height of the projectile must be less than d. And we know what is the maximum height of the projectile? H max we know, that is u square sine square theta upon 2g. This is the maximum height attained by the projectile from ground to ground projectile case. This is the maximum height you can say, and this maximum height should be less than equals to d. If I will say this is nothing but u square is nothing but, can I say this is 2gd upon what? Sine square theta, 2gd upon sine square theta. And what is the g? We are already said this is a gravity free space, so we will put the value as what? 2, only the electric field acceleration, that is E by m into d upon what? Sine square theta. So if I'll go for u, this u should be what? Less than, this is root over of whole things. The root over of whole things is what? 2 E by m d, and only you have sine square theta. If sine square root over you will do, only sine theta will be come. So what is the value of u? The value of u should be less than to this value, so that it will not hit at the top of the plate. It will not hit at exactly the top of the plate. What is the basic concept I used? H maximum should be less than equals to d. So H maximum is what? U square sine square theta upon 2g should be less than equals to d. Simplifying these things, only this is a gravity free space, so we have to put here electric field acceleration, and electric field acceleration is nothing but q e by m. This is my, I have preferred this is small q, so definitely I must put here small q. This is small q, and I'll just simplifying, this is the expression of the velocity. So if I want to project at what maximum speed I can offer, that maximum speed must be less than to this value. The maximum speed must be less than to this value, so that it can goes and not to touch the upper surface. I hope this scenario has clear to everyone. Do one more illustration to give the confidence to the student. Question 4, if you look at this question 4, this is scenario is like this. This is positive, this is negative. I'll draw like this. This is positive, this is negative. Here one proton has released, proton is positive charge, and here one electron has released. Exactly at this scenario, the expression of the electric field always from positive to negative, so field direction will be like this, and width of these parallel plates is d. And what I have did, I released electron and protons. The question will ask to you, which one will reach faster, or which one will reach to the other end of the plate faster rate. If you observe very carefully these questions, this is if you look at these questions, which one will be reach faster, electron or proton reach faster? If this kind of questions has framed, we must think about what we will think about. We must think that electron is, this is proton, definitely it will move like this because positive negative, so positive charge is always attracted towards the negative charge, so definitely it will move like this. Electron will accelerate it towards this direction, electron will be accelerated. Look at the situations, what it will do. It is released means initial velocity for both electron and proton will 0 because it has released, initial velocity is 0. I can use the formula S equals to ut plus half a t square, and everything I have said gravity free space, we are not looking the gravity into account. So initially both have released, so this thing is 0. So S equals to what? Half a t square. Here S is what? D equals to half. Acceleration is what? E by m, and this is what? T square. D equals to half these things. So t square, what will be expression is getting 2dm upon E, and if I'll say t equals to what? 2dm upon E root over. I hope this scenario is clear to everyone. Here 2 is constant, d width of the plate also fixed, electric field also constant electric field we are supplying, so everything is constant. So T depends on what? Mass and charge. T depends on what? Mass and charge. The charge of electron and proton both are being same, so I can say T directly proportional to what? M. T directly proportional to what? Root over of m, because charge, electron and proton having same charges. So greater is the mass, greater is the time taken, and we know that mass of proton is greater than the mass of electron, because mass of electron is 9.1 into 10 to the power minus 31 kg, and mass of proton is something 1.6 into 10 to the power minus 27 kg. So definitely the mass of proton is heavier than the mass of electron, so proton will take more time than the electron, so time taken of proton will be more than of the electron, so definitely electron will reach quicker as compared to the proton. So what will be my answer? The answer should be, I can write here, the time taken for electron should be lesser than the time taken for the proton, so definitely the electron will reach quicker because mass of the proton is greater than the mass of the electron. I hope this question is pretty clear to all my students. One more time I just want to repeat, this is positive plate, this is negative plate, so definitely electric field direction is like this. Width of the plate is d, proton and electron are released. The question has framed that which one will reach faster. If this kind of situation is given, released means initial velocity both of them is 0. So I concluded one important thing, that T, time is depend on mass and charge, but charge having electron and proton both having same charges, so T depends on mass. So this question can be framed like this. So proton mass is greater than the mass of the electron, so time taken of the proton definitely greater than the time taken of electron, so electron will be quicker reach to this end rather than proton. And this kind of questions also one can give you like this, alpha particle and protons. Alpha particle, rather than giving this question as electron and proton, someone can give you alpha particle and proton. A student must think this is, if this kind of things must be given, alpha particle, the mass of the alpha particle is 4 times the mass of proton, and charge of the alpha particle equals to 2 times the charge of proton. So here the scenario will be different because T depends on mass and charge. So in that case a student has to think about it. I am not doing this question. So mass of the alpha particle is 4 times of the mass of proton, and the charge of the alpha particle is 2 times the charge of proton. 2 times what? The charge of proton. These are the small information the student must have to be in the mind that can help the student to think about it. Let's do one more illustrations for the student perspective that can help the student to think their ability. Let me do one more illustrations. Suppose this is the scenario has given, this is positive plates and this is negative plates. This is positive and negative plates like this, and the width of the plate is d, you can say like this. Exactly at the mid, two particles, one is electron, another one is proton. Electron and proton, exactly mid means this distance is d by 2 and this distance is d by 2. Electron and proton has projected. If electron projected, definitely the electron and electron will be go like this and the proton will be go like this. The questions has framed and this length has given, this length is L is given. The questions has framed, if electron and proton have projected with same velocity, electron and proton projected with same velocity, These are simpler questions, but fundamentally it can improve the student. Projected with same velocity, whose deviation is more? Whose deviation will more? What is deviation, you can say? The height of the deviation we are talking about. It goes like this. So maximum height of the deviation of electron, if I'll say this is y1 and this is y2, we have to think about it. If the electron and proton are projected with same velocity, whose deviation will be more? If this kind of questions are given, we have to think about, we have projected with same velocity, so I'll say I'll project it with velocity v. So in this questions as given, we have to think about y1. y1 is nothing but, we can use that formula that s equals to ut plus half at square, but in vertical velocity, initial vertical velocity is 0, so only I can use half a t square, and I know everything is talking about the gravity free space, so a can be written as e by m, and this is t square can be written as t, I can using the horizontal, I know v equals to s by t, so t equals to s by v. What is s? This is length upon v, so I can substitute here L square upon v square because t square is given. This is t equals to what? L by v. This is my y1. Similarly, y2 is nothing but this is, if I'll think about proton, this is half, this is electron, I'll say this is proton, electric field, mass of proton, L square by v square. I already said both having same velocity. If I'll make a ratio of y1 by y2, what are the things will come out? This is mass of electron, so everything will be cancelled out. I'll get, because same velocity, I will get mass of proton upon, this is mass of y1 upon y2 I will do, so mp, this is me, and QE, this is QE, make a ratio like this, so QE, these things, mp goes this side, so this is electron, charge of electron upon charge of proton. So this is the relationship is coming like this, this is my relationship that is coming like this. And if you observe, they have projected with same velocity, and we are getting this kind of ratio that y1 by y2 mp by me, and this is E, but we know the charge of electron and proton is same, so these things have been cancelled out, so definitely we'll get y mp upon me, and we know that mass of proton, it means the deviation is inversely proportional to mass. The deviation is inversely proportional to mass because the first one is for electron and the second one for the proton. So definitely this electron is mass is inversely proportional to like this. It means whose mass is greater? Mass of proton is greater than mass of electron. So definitely the reverse will become, so electron deviation will be more than the deviation of the proton. This is greater than 1, this mp by m1 is greater than 1, so definitely this parameter electron deviation will be more as compared to the deviation of the proton. So in this case what will happen? The electron will more deviate as compared to proton. The electron will be deviate more as compared to proton. So this is, I hope this question is pretty clear. These are the fundamental questions: positive, negative charges. You projected with velocity v, which one will be deviate more? If you projected with same velocity, will reach to this result. We are reaching to this result. Similar fashion, if we'll talk about the same questions can be framed if electron and proton is projected with same momentum rather than same velocity. If I'll say same momentum, both the things have been projected. Electron and proton have projected with same momentum. Here the relationship is here. Look at the relationship. So what is the relationship is coming? Y1. Now you can easily understood Y1 by Y2. If I'll do, this is exactly coming what? Look at these things, make a ratio. Charge of electron and proton same. So we will only look at these things. What is the things? This is mp v square upon me v square. And the questions as already framed, they are projected with same momentum. Please make a ratio here. Everything will be cancelled out. Rest of the things will be like this. And I already said if the electron and proton are projected with same momentum, it means I must make it to be square. So what are the mp v square, mp v whole square. This is me v whole square. So I have to divide one mp here and multiply one me here. This is simple mathematics. A student has to think about it. And I already said both having same momentum, this parameter will be cancelled out. So y1 by y2 equals the result came me by mp. And we know that the mass of the electron is much more lesser than the mass of the proton. So this parameter must be less than what? 1. So what will happen? Y1 less than Y2. So it is very clear that proton will be deviate more rather than what? Electron. If the two particles, electron and proton, are projected with same momentum, then there is a possibility that proton can deviate more as compared to electron. If it is projected with same velocity, one can say that electron will be deviate more than the proton. The deviation of the electron will be more than proton. If it is projected with same momentum, the deviation of the proton is more than of the electron. Similar fashion, the question C can be framed if they are projected with same kinetic energy. Same kinetic energy if they projected. I already know the relations very clear. That is y1 by y2. That is mp v square and this is me v square. I need what? Kinetic energy. So I will multiply half everywhere. This is mp v square. This is half, I multiply me v square. If you observe carefully, they are projected with same kinetic energy. This factor ratio is 1 and we are reaching a very heuristic conclusion that y1 equals to y2. So it is very clear if the electron and proton have projected with same kinetic energy, their deviation will be same. It means the how much deviation height will for electron, the same deviation height for the proton also, they will be both same deviations. So one more time I want to repeat for my student. Same velocity, electron and proton, electron will be deviate more than the proton. Same momentum, electron and proton, proton will be deviate more as compared to electron. If same kinetic energy, electron and proton deviate equally. The deviations height will be equal. I hope this scenario is pretty clear to everyone. Thank you everyone. Thank you for the watching.